Day 629 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3507, minimum pair removal to sort array 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Sorry, y'all. Let me get rid of this. All right, let's see. It says, given an array nums, you can perform the following operation any number of times. Select the adjacent pair with the minimum sum in nums. If multiple such pairs exist, choose the leftmost one. Replace the pair with their sum. Return the minimum number of operations needed to make the array non-decreasing. An array is said to be non-decreasing if each element is greater than or equal to its previous element, if it exists. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 5, 2, 3, and 1. The output is 2. So that means it took 2 operations. So let's look at the explanation to see what those 2 operations were. It says the pair 3 and 1. Sorry, y'all, the pair 3 and 1 has the minimum sum of 4. After replacement, nums becomes 5, 2, and 4. So let's break this down, right? So we want to find the minimum sum of an adjacent pair, or we want to find an adjacent pair with the minimum sum in nums, right? So in this case, 3 and 1 have the minimum sum, right? Because if we did 2 and 3, that has a sum of 5. And if we did 5 and 2, that has a sum of 7. So since 3 and 1 has a sum of 4, and that's the minimum sum, that's the smallest sum that we can create, that's the adjacent pair that we're going to go with. It's important to remember we can't do 2 and 1 because they're not adjacent. It has to be an adjacent pair, meaning the numbers have to be next to each other, right? It can only be 2 numbers because it's a pair, and they have to be adjacent, meaning they have to be right next to each other. So that's why we can't do 2 and 1, which would be 3, because they're not adjacent. So with that being said, 3 and 1 is going to have the minimum sum out of all of the adjacent pairs in this array. So we replace 3 and 1 with 4. So that's after the replacement, nums becomes 5, 2, and 4. So let's just act it out over here, right? Boom, we have 5, 2, 3, 1, right? Boom. So we're going to take this adjacent pair and we're going to replace it with 4. Boom, now we have this. Then it says the pair 2, 4 has the minimum sum of 6 after replacement and becomes 5, 6. So then we could do this pair, which would be 7, or we could do this pair, which would be 6. We want the minimum pair, so we're going to go with this pair, which was 6, and then after that, it looks like this. Boom. Now, as you can see, we want to get the minimum number of operations needed to make the array non-decreasing. And then it says an array is said to be non-decreasing if each element is greater than or equal to its previous. So it just means it needs to be sorted, right? Meaning like 1, 2, 3, 4, 5, 6, 7, all the way up, right? It has to be non-decreasing. I don't know why they say non-decreasing instead of just saying increasing, but same thing. So as you can see, it goes 5, then it goes 6. That's increasing or non-decreasing, however you want to look at it. But either way, that took 2 operations to make this array, this array right here into a non-decreasing array. As you can see, this is not non-decreasing because it goes 5, 2. That's decreasing. We want non-decreasing, right? And this right here goes 3, 1. That's decreasing. We want non-decreasing. So that's what they mean by non-decreasing. In the end, we're just returning the minimum number of operations, and in this case, it would be 2. Boom. So now that we know example 1, let's take a look at example 2, where if they try to throw a trick question our way, where the array is already sorted. So in example 2, our input nums equals equals an array of integers 1, 2, and 2. The output is 0 because we didn't need to perform any operations to make this non-decreasing. Hence, the explanation saying the array is already sorted, right? We don't need to change anything. This is already non-decreasing, or it's already sorted. So we could just leave it as, and we didn't need any operations to do that. Boom. Now, Now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult. Now, first thing we're going to do is make a mutable copy of the input array since we'll be modifying it. So we're just going to declare a variable called nums, and nums, and we're just going to set that equal to nums. Boom. And that is going to make this nums mutable. Boom. Then we're going to count how many merge operations we perform. So we'll say var ops equal 0 for operations. Then we need to reset until, we need to repeat until the array becomes non-decreasing. So we'll say while true, we're going to open up the brackets. And we're going to assume the array is sorted until proven otherwise, right? In case they try to throw a trick question like example 2. So we can say, we're going to start it as sorted by saying var is sorted. We're going to set that equal to true. Boom. Then we're going to come underneath that, and we're going to track the minimum sum of any adjacent pairs. So we could come right here and declare a variable called min sum, and we'll set that equal to int.max just to start. Now we need the index of the left element of the pair with the smallest sum. So we could just declare a variable called op idx, and we'll set that equal to -1 just to start. Boom. Now we need to iterate over all adjacent pairs with their index. So we're going to open up, we're going to come right here, we're going to say for, open up these parentheses, I, comma, open up some more parentheses, A, comma, B, come outside the parentheses, we're going to say in nums dot adjacent pairs, put the parentheses, dot, enumerated, enumerated, boom, put the parentheses, make sure that's spelled right, open up the brackets, and if the adjacent pair is decreasing, the array is not sorted. So we'll say if A is less than, if A is greater than B, then we'll open up the brackets and we'll say is sorted equals false. Boom. Then we're going to track the adjacent pair with the smallest sum. So we're going to come underneath this, and we're going to say if A plus B is less than min sum, then we'll open up the brackets and we'll say min sum equals A plus B. Boom. Then we're going to say OP IDX. We're going to set that equal to I. Boom. Now, if the array is already sorted, we can stop processing and break. So we're going to come right here and we'll say if is sorted, we'll open up the brackets and we'll say break. Boom. Otherwise, we're going to perform one merge operation. So we'll come underneath this and we'll say ops plus equals 1. Boom. Now, we're going to merge the selected adjacent pair by adding the right value into the left value. So we'll say, come underneath this, and we are going to say nums square bracket, OP IDX. Come outside of that, we're going to say plus equals, nums, open up the brackets, OP IDX plus 1. Boom. Now we're going to remove the right element of the merged pair by coming underneath this, and we're going to say nums dot remove, open up the parentheses, at colon OP IDX plus 1. And then we need to return the total number of merge operations performed by coming right here, and we could just say return OPS or ops. Boom, y'all. That should be all she wrote. Let's give it a run. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. Yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.